where it is being applied. So there are some quiz also. So you might note the key points regarding this training. So the aim of any production or any plant is to improve quality through decreasing the costs or decreasing the defects. And what it will give you improvement in productivity, it will decrease your price or manufacturing cost, you will be able to increase your market, you stay in the business, you provide more jobs, and you get more return on investment, that is ROI. So this is called as Deming chain. And how we can get this? Through use of 7QC tools. As the screen mentions, these are called as the old 7 or the first 7. These tools were initiated by Mr. Kaoru Ishikawa. He was a professor at Tokyo University, and he is also known as the father of quality circles. So these are the 7QC tools that I'm sharing. First one is flow diagram and check sheet, Pareto diagram, cause and effect diagram, graphs, and various control charts. Then we have histogram, the stratification, as the name stratification means segregation into minute pieces. And last one is scatter diagram. So we will start with the first QC tool. So first one is flow diagram. It shows how your operation happens, what is the sequence of your operation. So it gives you a schematic drawing, and it needs very minute details of your production process. So there are some symbols, as you can see on the right side. There are some symbols like start, stop, or operation, where you are making decision in terms of any inspection related activity, whether it is okay or not okay, or need rework or needs segregation, like that. So what is the input, output, and flow lines means up or down or left or right, like that. If there is some storage, then the triangular mark is there. In case of any transportation, that is from receipt to your store or dispatch from your plant, the transportation symbol is there. And in case of you are doing any measurement or inspection activity, then the square symbol is there. So all these symbols, all this flow diagram gives us the exact location. You can trace out where is the problem occurring and at which activity the problem is occurring, that you can get mentioned. So this is nothing but a flow diagram at our plant. It starts from raw material receipt, and it at 10 number, process number 10, and it ends at process, that is dispatch. So the flow diagram is is accompanied with check sheets. The check sheet, as you can see, in every industry, in not only automotive or production industry, in each industry, that is IT industry or service industry, we need to have proper data to measure our progress, or to, what I can say, to point out any defect, to locate the particular defect detection or location. So we need to have check sheets. So check sheet is nothing but a systematic and organized collection of data. So it is useful to determine source of problem and to facilitate at stratification. So in right hand side, you can see here operator A in morning shift, he is producing he has x number of rejection, that is one number of rejection. In machine 2 also same, but in afternoon shift he is producing 2 number of rejection at machine 1 and 6 number of rejection at machine 2. Operator B, he is rejecting many parts in machine 2. So we can see there is less chances of operator, but there are more chances of machine that is contributing to any rejection. So this gives our focus on machine 2, and that too in second shift or afternoon shift. So this is a basic what I can say, giving focus on the priority or the location. The second QC tool is Pareto diagram. The purpose of Pareto diagram is to prioritize problems. So as you may have n number of problems in your industry, so how to, where to focus? So that is our main question. One interesting thing that the person who invented this was Vilfredo Pareto. He was an Italian engineer in 19th century, and this principle was regarding some, you can say, political scenario. So he had studied and he has declared that 20% of people owes 80% of country's wealth, and 80% of people owes only 20% of country's wealth. And this is true in today's scenario also. I am not going to divert my subject, but this principle was invented by Mr. Wilfred Pareto, and same principle we are going to talk in this training. So it applies nothing but a few causes lead to many defects. So vital few and trivial many is the basic principle. So we need to act upon vital few. How that it is being shown. So these are the defects at our plant, Saint-Gobain plant. So pocket, chips, trolley breakage, bubble, and waviness are the major defects that is contributing major rejection in at our end. So I will show you how to plot. So you can write down the defects and the rejection number as per this table. Then segregate it or sort it from highest to lowest. You will get percentage also with respect to total. Now this is with respect to total. The second table is with respect to cumulative. So as you can see, I have segregated it from highest to lowest. I have given the rejection number. 137 by 237 is 57.8, 38 by 237 is 16, and I have done cumulative. 58 plus 16, 74, 74 plus 10, 84, 84 plus 6.3, it is 90. Like that, I have made cumulative rejection. And based on these yellow highlighted columns, I have prepared one graph that is showing this thing. On bar chart, it is rejections, and in line chart, it is rejection percentage cumulative. So you need to have two axes. So actually, this graph is also not complete because, now we can act upon basic two problems, that is pocket and chips, and it will yield to 74% of rejection. So we need not to focus on these trivial many, we need to focus on vital few. So if we nullify or if we did act upon these two major defects, we will be able to solve our 74% of problem. So as I mentioned, vital few are these only, and trivial many are many like this. The actual representation of this starts from the top of first column. So this is your homework to draw two axis graph from starting with the top of the bar chart. If you face any problem, you can come to me, no issue. I hope you must be remembering this match. That was what I can say, a major defeat to Australia, our old rival. The match took place in Eden Garden on 14th March, and India were at Australia had first batting and they had made 445. India were all out in 171 and got follow on. In next second inning, in next inning, India made a gigantic score of 657, out of which VVS Lakshman and Rahul Dravid, they made their significant contribution. Australia were all out in 212 in their next inning, and India won by 171 runs. So you might be guessing what is the correlation of this at our end. So this was the correlation. Harbhajan Singh took 6 wickets, Sachin Tendulkar took 3 wickets, and this was the summary. They made Tendulkar took 90% of wicket. So here also the Pareto principle works. So 20% of batsmen played very well, and around 30% of bowlers took majorly 90% of wickets. So this is the principle of Pareto. Now we will move to cause and effect diagram. So this is third basic tools. Actually, any action or any incident that is correlated with the root causes. So our effect is an result of many causes. So as you can see, this diagram consists of one what I can say. This diagram is also called as fishbone diagram. As you can see over here, if we dried the fish, then here it will be with the bones, the mouth, and this diagram was invented by Mr. Kaoru Ishikawa. So as earlier mentioned, he is also known as the father of quality circle. So he is the inventor of cause and effect diagram. So it is having basic 6 elements: man, machine, material, method, that all must be knowing. Another is measurement and environment. So small bones, it represents root causes, or the medium size bones like this are the secondary causes. So what it needs, that you need to visit your Gemba, that actual workstation, and you need to discuss with operators. You need to check condition, machine condition, the flow, material flow, that is method, then SOP, standard operating procedures, everything you need to check, and then you need to stratify stratify the actual causes. So as you can see, there are 2 steps for making this cause and effect diagram. First one is to identify all causes. All causes means all possible causes that are contributing, that may contribute. The second one is to identify actual causes and classify them. So the next one is probable causes, and there is one method to collect most number of causes, that is brainstorming. So this activity is not done by one person, it is a team activity. So brainstorm is nothing but to collect or to obtain creative ideas from group of person in shortest possible time. Then means persons from maintenance, persons from operations, quality, maybe from HR, then projects. All these persons sit together and generates the ideas or the causes, what may be the that have contributed to the failure or the defect. So brainstorming, why it is being used? To identify problems and to prevent the problem. So once the problem is identified, then and then only we can prevent it. How? by finding the situation, by finding the solution. And if we are not able to find out any actual solution, then we can identify that area as a critical area and we can act upon that critical area. So brainstorming is done in two ways, that is conducted in two ways. One is structured and another is unstructured. As mentioned in structured, every person in group must give idea. uh, it focuses on even shy people because it is a mandatory to give idea, and it creates certain pressure that the shy, it is about the for shy people, those are hesitating to represent themselves, but it is a pressure, it is a positive pressure. Whereas in unstructured, the people who are more extrovert, they gives many ideas, but the rules are there that all members shall speak freely to give idea, and there should not be any restriction on quality of idea. Means you should not judge whether it is possible, practicable, or anything. You should just note down. So more ideas will be only written down. The analysis will be done in next phase. So you shall not make whether it is good or bad or it is not possible or something like that. You should let your brain free, or the let team members brain free to generate more and more ideas. So if possible, non-members also can be involved. So you may take opinion from other departments also. So based on the generation of ideas or the causes, we will come to the solution because we have found out the problem. Then we will act upon the causes and we can come up, we can derive the solution from for that problem. So coming to the fourth tool, that is graph and control chart. So graph and control chart means it gives you the earlier we have seen the actual happened problem is happened. So these are the reactive tools. Now this graph and control chart gives us an advantage to predict the expected product outcome. So based on the trend, we can predict whether the process will be within our specification or it will be out of our control. That we can predict. We can distinguish the relation between two specific parameters, and also we can distinguish or we can identify possible causes of variation. And these graphs and control charts are mostly used in statistical process control. So it is these graphs, as you can see, there are two data. One is variable data, another is attribute data. So basics of this variable and attribute is if we are measuring diameter of a shaft, so we can the number of shafts is 10. So there will be actual numbers of that diameter 10.1, 10.2, 9.8, 10.3, like that. So this is called as variable data. We are not doing any analysis whether the diameter is okay or not okay. But if we check the condition of that shaft, whether by using go-no-go gauge, we have one go-no-go gauge and we are just inserting shafts in go-no-go and we are collecting the information about whether the shaft is okay or not okay, shaft diameter is okay or not okay. Then that data is called as attribute data. So variable data gives us the number, attribute data gives us the result. So to prepare this control chart, we have these many types of chart: X bar R chart, X bar S chart, IX, that is moving range chart. This is for variable data. And we have P chart for fraction defective or constant n. Then we have if n, that is number of numbers are changing, then we have p chart. We have c chart for constant n, that is count data, and for changing data it is u chart. So these are the different types of visual attribution of X bar R chart. So you can see if the subgroup is 2 to 10 or less than 10, then X bar R chart is used. If subgroup is more than 10, then X bar S chart is used. So along with this, you need to prepare upper control limit and lower control limit. Similar for X bar S chart. So upper control limit and lower control limits are derived, and based on that we can see whether what is the trend of this thing, the graph or the process is going towards. So you upper control limit and lower control limit formula is shown over here. I will not go to in details. It contains some numerical this thing. So this is moving range chart. This is moving range chart, means the actual productions or actual parts dimension is being measured and plotted on the graph. So these are for attribute, that is okay or not okay type of chart. This is P control chart, and its formula is given for upper control limit and lower control limit. The bottom one is NP control chart. It has its own calculation method. The next one is graph. So as you can see, graph is correlation of two data sets, x-axis and y-axis, and based on that we can see the correlation between two numbers. We can see the trend and percentage of totals that we are able to see through this graph. So for graph it is very necessary, it should be correctly understood in their entirety. We shall not miss anything in between this thing. It should give us entire batch, entire data projection, and it is very easy to see within just one look whether it is going down, going up, going steady, or like that. So as you can see, there are many types of graphs: bar graph, line graph, pie chart, band graph, radar chart, or Z chart. So we will discuss in brief about these different types of graph. So this is a bar graph. The next one is pie chart. Then this is a radar. This is Z chart. It gives you monthly, YTD and 12-month average in totality. Then we have band chart. Band chart, you can see it is nothing but a moving range chart. Each each product's parameters are being calculated and it is shown in a graph. So these are types of charts: line chart, pie chart, surface, radar, tree map, histogram, waterfall, funnel, and in combo we can have multi-axis graphs also. We have histogram, as it mentions. It is also called as ND curve, normal distribution curve, and this was invented by Mr. Gauss. He was a German inventor, and the Gaussian curve is nothing but a normal distribution curve, and it is there present in currency note of Germany. So they have given the importance of this normal distribution curve on their currency also. So this is nothing but a graphical representation of group of data points and our specified ranges, user specified ranges, what we want to specify in number of range. So as you can see, there is x-axis, y-axis, and the y-axis is bifurcated into number of ranges, and the repeatability or the number of characteristics that falls upon the number of participant that falls in the range, it is mentioned in graphical format. So it gives you a more clear concept than mean or standard deviation. The earlier in our earlier charts we have seen the standard deviation. It was majorly used in earlier charts. Here it is gives you a very clear picture of distribution of data. So normal distribution, this is called as normal distribution or bell curve. So this is a commonly used type. It gives you whether the process is in center of our parameters or within center of our specification. So it tells about the symmetricity also. So we can see there are four types of this normal distribution curve. One is positively skewed. That means the major area is concentrated on one side of axis. So most of the values are lying on the lower part of specification. If it is negatively skewed, you can see the major part lies on the next part of axis. Then another is bimodal distribution. That peaks are, there are two peaks or multiple, there are two peaks but very having two bell-shaped curve. So one major range lies over here and another major range lies over here. The fourth one is multimodal distribution. Multimodal distribution shows there is no correlation between the x-axis and y-axis. So we have seen now histogram control charts to check whether the process is normal or not, whether we are getting a normal bell-shaped curve that is being seen from the histogram. If we want to see whether our process is stable or not, like we have seen ups and downs, but if it is not going upward or the process is not going downward, then that means our process is stable, and that we can see from our control charts. And process capability. Process capability tells about the CP, CPK. These are the terminology being used for statistical process control. Process capability and process capability index. CP means process capability, and process capability index, that is mentioned by CPK. So it tells about whether the process is capable as per our requirement or not. So generally 1.33 is the standard requirement in case of CPK, and 1.67 production capability index, that is PPK, for new production setup. So the next area is stratification. Stratification means fine-tuning of the data. So how we can stratify the data, or how we can put it in different pockets so as to arrive at exact location of the problem. So here we can see it, or we can check it through one case study. This is a theoretical case study. So reportable accidents are 8 numbers, non-reportable accidents are 33, near miss incident are 21 numbers, lost time injuries are 41, and we have lost man days 187 numbers. So reportable accidents, non-reportable accidents, and lost time. It is being mentioned that reportable accident means operator is not reporting within 48 hours. So after 2 days he is not reporting. He has not joined the duty. That is reportable. If he joins back within 48 hours, it is non-reportable. And lost time injury is equal to reportable plus non-reportable. So we are going to analysis for these incidents. So according to category of employee, we will stratify the data, and we can see 30% accidents are with related to contract labor, 38% accidents are with related to temporary workmen, and regular employees, 4 numbers, have contributed 49% of accidents. According to phenomena, so adjusting or cleaning activity, that has contributed 6 numbers of accidents out of 8. Wrong handling of material handling equipment, that has caused 2 numbers of accidents. Further, if we dig down, we can see finger related accidents are more, 62%. Hand related, it is only 13%, and leg related, it is 25%. That is 2 numbers of accidents. According to plant, so it had happened in whole area. So there are 2 production centers. One is plant 1, sorry, 3 production centers. One is plant 1, plant 2, and plant 3. So in R&D, it happened 1. In specific warehouse, it happened 1. Other area, it happened 1. In plant 1, there was nothing. In plant 3, there were 2 accidents, and in plant 2, there were 3 accidents, contributing highest, that is 37%. So according to unit, it is being mentioned. In plant 2, it has happened 3 numbers, and in plant 2, fabrication, engineering unit, and paint have contributed each accident. In plant 3, it was machine shop that has contributed to 2 numbers of rejection. In other areas, it was contributed by R&D, stores, warehouse, and civil work. So you can see now the further deep down, we can see in A shift, 4 incidents were happened. In second and night shift, each 2 accidents happened. According to month, this is the data for a full year. In May, it contributed 3 accidents. In October, 2 accidents happened. In December, January, and March, 1 accident happened. According to fault, whether it was it is related to like 4M chain, 4M or 6M analysis, fishbone. You can remember the fishbone. So whether machine man related was there, whether it was method related, or environment, light, insufficient of light, or that related. So you can see we have bifurcated into as per fault also. So we have stratified the data as per employee category, as per phenomena, as per body part, as per month, as per plant. In plant also, we have segregated in unit wise, shift wise, then as per fault wise. So this gives us a very clear picture where to act upon, and it is not the act should not be on person. The act should be to prevent such things to happen. As per ISO guideline, we should act upon the actual data. So facts based approach shall be followed, and not person based approach. So the person can commit a mistake, but we shall prevent the person from committing a mistake by giving him proper training, proper machine, proper infrastructure, and how that we can see from this type of stratification. So this is stratification that is being deployed at our plant. So if we want to, this is earlier case was regarding the happened case, the reaction. This case demonstrates our proactive phase. If we want to improve our profitability, these are the site objectives. So if we want to improve the profitability from this to this, so based on this, where we will fall, how much we should improve. So by this is my work center wise targets I have derived. Then in work center, that is marked over here, furnace, I need to improve from 98 to 98.2, and this is related with the actual process, the next furnace, and how we will improve our productivity by reducing the rejections. So these are the rejections that we need to reduce, and by virtue of reducing this, we will improve our process yield at machine 1 as well as at machine 2. That will improve my furnace efficiency, that will lead to my improvement in overall process yield, that will give me a good improvement in profitability. So this gives me stratification on a proactive basis. The next QC tool is scatter diagram. So it is done to check whether there is a correlation between two variables. So you need to have 30 to 100 data points, paired data point, that is 100 measurements, and just find out the highest and lowest value of both variables. And then we will plot the x and y axis of graph, and we will check whether there is any correlation. So as you can see, there is correlation between here mentioned as time for loading of operation and number of workers. So if number of workers are getting increasing, then the time for loading is getting reduced. So this is nothing but a direct correlation. If I am increasing my number of workers, it will give lower number of loading operation. However, after these two, we can see there is one stagnancy. So although we put many number of workers here, the time will not drop down much further. So this is called as my optimum numbers. So this is also can be derived for my calculating my cycle time or optimizing my cycle time against number of workers. So how to read these scatter diagrams? So there is direct correlation, that is called as positive correlation. There is negative correlation, as we saw in last figure, number of operators versus number of time. So if I am increasing one particular parameter, it is getting increased, that is positive. If I am increasing one parameter, the next parameter is going down, that is negative correlation. There is possibility that positive correlation may be present in third diagram. You can see, but again it is decreasing, again it is increasing, there is decreasing, but overall if it seems to be increasing. So positive correlation may exist here. Similar for negative correlation, if we take one trend line, then we can get a downward this thing. So we will see a negative correlation that is present over here. And if we come to see, if we observe such type of diagram, we can straight away say that there is no correlation between x and y. So the problem lies at somewhere else. So as we have seen, our tools, that is check sheet, Pareto, stratification, cause and effect, that are used for different types, means problem identification, then our observation for analysis, taking action, then there is check, standardization, and horizontal deployment. So as you can see, check sheet is used for problem identification and observation. Pareto diagram, yes, to check the problem identification as well as giving the importance or the priority where to act upon. Stratification gives us observation, helps us to see any observation between two variables. Cause and effect diagram gives you a clear root cause analysis, that is for analysis. Histogram, it is used for problem identification, observation, and to check in which group the problem is lying. Scatter diagram, as it mentioned, it gives you analysis purpose, different charts, those are used for analysis as well as standardization. Then problem identification or observation also, whether it is happening or what is it's giving trend, so we can use it for standardization also. These are the later stages, that is DOE, design of experiment, test of significance, Viva analysis, PM analysis, and Gantt chart. So these are nothing but the other tools that can be used for problem solving. Check sheet is used for horizontal deployment. So if we observe a check sheet which is useful at work center 1, similar check sheet we can deploy it at next work center. So this is nothing but to prepare a QC story, quality control story. So these are new QC tools. As I mentioned, we have seen the old one or the basic 7. So these are new QC tools. The affinity diagram, interrelationship diagram, tree diagram, priority matrix diagram, process decision program chart, and activity diagram, activity network diagram. So we are not going to see these new 7 QC tools. We can see it in next year's Mahavir Education Trust Atal program. Till now, as of now, we are going to see only the basic 7 diagrams only. So herewith I am concluding my training session or seminar or discussion with you. If you have any query, doubt, or need any specification, I am here very well open to discuss in details.